Talk about Angular. So Angular is a framework that allows you to build single-page applications. Right? It's uses the language called TypeScript, which is a superset of the JavaScript language, and it introduces features such as obviously object-oriented technology, just like ES6, but it also introduces types, data types. One of the criticisms of JavaScript is that it's a weakly typed language, right? And there's no validation. And this causes some concerns or some challenges when you're going to debug it or when you're going to create some unit tests, right? That oftentimes you find yourself debugging code that is running code as opposed to debugging something at compile time. Right? You would like to be able to find errors as early as possible, right? Not when it's already running. You like to be able to do it at compile time. It says, well, no, this won't compile because it's the wrong data types. You're passing the wrong thing. So you would like to have even the IDE perhaps help you out and saying, hey, you can't assign that to that, right? Because they're not of the same type. So by not having types, JavaScript makes it a little more challenging, right? To make sure that the quality of the source code is of high quality. So TypeScript adds the capability of being able to add types, right? Be able to strongly type your parameters, and it does all the validation for you, making sure that things are being passed correctly, right? It introduces also several other things such as generics, right? That's also is very popular in other mature languages such as Java or C# or any of these object-oriented or component languages. Introduces inversion of control. It introduces a lot of features, right, that we've come to take for granted and that we've been using for decades on the server side. And says, hey, this has worked very well on the server side. Why don't we bring some of those ideas into the client side development? Okay, all these abstractions, all these techniques that we've developed on the server side, they're all geared towards making it easier for us to implement better software. Okay, we come up with all these good design patterns, right, that we've been discovering for decades. Singleton patterns, factory patterns, facades, all these patterns that we've been identifying for decades. Says, well, we could apply some of those techniques also to the client side, and the reason is that the reason we implement these design patterns is because we are implementing more and more complex applications. These things are growing, right, and we need to be able to create all these abstractions that allow us to break up these large applications into smaller chunks, right, and abstract out some of the details so that we can focus on what's actually important. So Angular introduces all these great ideas and brings them onto the client. Okay, so it's a much more ambitious take on implementing front end user interfaces, right? As opposed to React, really is a library for doing dynamic content generation, right? It's it doesn't really React doesn't really care how is it that you go fetch data from the server. It has no opinion on that, right? We were using a singleton pattern, right? But it's because we decided to do that. We did a little class that had like a get instance and all that, but that was our decision. React really has no opinion on how is it that you fetch data. Has none of these very high level abstractions of inversion of control, generics, none of that, right? It's just a very simple, down to earth, very easy to just here's some data, apply some component technology to build fairly complex user interfaces, right? So Angular has a much higher learning curve, right, than React does, right? But my hope was that by introducing React first and talking about components and talking about single page applications and talking about fetch and how to fetch data from the server, we already hopefully we are confident enough that we don't have to cover any of that when we talk about that in Angular, yes? That we already understand what component technology is, how to build components, one in terms of others, that they have to talk to one another somehow, that there's some state that you have to maintain on the client, yes? So we already have all that down pack, hopefully. And so hopefully the learning about Angular will only be an incremental step, as opposed to having to learn what the heck is a single page application, what is components, what are all those things, yes? And also the syntax that we've been using all along, ES6, translates very nicely to the syntax of TypeScript, right? So still we wouldn't have to do exports, we wouldn't have to do imports, arrow functions, maps, all that still applies. So all that we've been learning from React is still applicable. The concept is still applicable in Angular. Another thing that Angular became very famous or very good at is that at first a lot of people welcomed it. Perhaps today folks might feel different, but they brought in a lot of the things that again we learned on the back end of breaking up large applications into chunks, right? Into divisions of concern, to divide the different concerns of an application. Yes, an application, as we saw in the diagram up there, the architecture, there's a concern of rendering stuff for the user. Yes, and there's a whole family of concerns that go along with rendering things to the user. It needs to be pretty. It needs to it has to be it has to have padding. It has to be a good use of white spaces. It needs to be consistent, a good color scheme. So there's all sorts of concerns of implementing the user interface, yes? There's also a lot of concerns on how is it that we're going to store this in the database, yes? And there's a whole family of concerns. How do we do that? How do we map this one-to-one, one-to-many mappings, association classes, foreign keys and primary keys. There's a whole body of things that you need to deal with that, right? Also, there's how do you handle all the events as user interact with the application? How do there's a stream of events as user type on the keyboard and move the mouse, and there's a whole stream of events that go out to the client to some controller that has to deal with these events and then serialize them and deal with them and handle them. Yes, there's a whole body of concerns. So there's a very popular architecture that became very, very popular, a couple of decades ago, called the MVC architecture, right, or model view controller, right? That that became very, very successful at how do you think, how does you go about thinking about building an application? And there's really three huge buckets of things that you need to worry about. One is modeling, the M in the model. How is it that you model the data, right? The relationship between the data. If it's going to be arrays or strings or objects within objects, embedded objects, how is it that you model that? So that's one bucket of concerns. The other one is the view, which is the rendering of the content for the user as the user consumes the data. Yes, and the other one is the control layer, which is the concern is to handle all the events that the user generates as they click and drag and interact with the application, and then we have to convert all that stream of events that come from the view, and we have to convert it into modifications or mutation of the state of the model, right? So it comes from the view. We handle all those events in the controller. The controller modifies the model, and then whatever the result of that model, the controller sends it back to the view for rendering. Yes, and there's a back and forth of data flowing from left to right and whatnot. Yes. Now React. Took the especially alongside with Redux, kind of took a different approach to this, right? Where we should be able to think about the data flowing only in one direction. The Redux state flows into the container flows into the component, and then it's rendered, right? It's a particular way of thinking of applications that. And an easier way of thinking of the application that there is no mutation, right? There's no state mutation. You don't modify the state, you create a brand new state, right? So if you think of the reducer, it never actually modified the state, right? It just did a brand new version of the state. So the data seemed to always flow one way, right? The state was generated, it flowed to the container, down to the component, and then for the user consumption, yes? Again, one way of thinking. Whereas Angular is still model view control. The data flows and the state is mutated over time. So Angular provides different abstractions for us to be able to think about the application in terms of these three concepts: model, view, and controller. Yes. Whereas React doesn't really care, has no opinion on how is it you break up the application. Actually, React takes the notion of embedding together, perhaps some JavaScript embedded together with some HTML, right? It makes it actually very easy for us to do that, right? Using render function and the return, we can embed HTML inside of JavaScript, yes? Right? And React doesn't really care. Whereas Angular is very adamant about splitting that up. It says, no, we're not going to mix JavaScript and HTML together. We're going to clearly make a very clear distinction here that HTML is only for the view and JavaScript is only for the control layer, right? And there is no intermix in between the two, right? It's a very clear division of labor. Now, in React, we sort of do that, right? When we break up components into two types, which is the container, and we take the component, we sort of are using a little bit here the C and the V, where the container is holding all the JavaScript that handles the events, yes, right? Whereas the component, the only concern of the component is to receive data from the outside world and just render it, and look pretty, right? And just iterate and map the data that it comes in through the properties and only render it, right? And it has no concerns of handling any of the events. Instead, the functions are fed to it through the component, through the properties, yes? And then any clicks or drags are sent back to the container, who's actually going to handle the events, yes? So in that sense, React also kind of went that way, not because the language or the framework forces you to do it, but the developers found it to be a nice, clean way of breaking up that division of concern, right? We're going to have stateless components, only do the rendering, and then we're going to have containers that do have a state that have all the event handlers. See that? It's a little bit what Angular did, but Angular is very clear about that distinction. One of them is only going to have HTML, no handling, and whereas the other one is going to have component all JavaScript, or TypeScript in this case. Right? Again, learning Angular. A lot of the things, concepts that we learn in React are applicable here. Component technology, services, HTML, CSS, obviously, server communication, blah, blah, blah. All that is still applicable here and hopefully will make the learning curve of Angular. Angular has a very steep learning curve. Now that we've covered React, hopefully that learning curve will be much shallower, okay? Since we don't have to relearn a lot of the concepts. All right, so to get started with Angular,